Okay, I wanted to make a quick video of what we did on the Google Meet so that you know. So when we ended the Google Meet, this is what you need to complete for today. So you need to launch your catapult 3 times. You're going to figure out how much time it spent in the air. Was it, 2 seconds and it went 50 centimeters? If you want to measure in inches, you'll just have to convert it to centimeters. If you want to videotape it on your phone to figure out the launch time, if you have a partner that can help you, someone at your house to help you measure the timing. If you're really stuck on this, you could email me to get some just kind of trial data. But you're going to do 3 launches, find the average time, 3 launches, find the average distance, use your averages to do your own calculations. So I'm going to show you the calculations that you need to do. This is on Google Classroom if you want to refer to this page posted for today. So your first step is just realizing this is a parabola, and we're trying to locate the vertex of this parabola. So here's how you do it. Your x value of your vertex is going to be half the distance that you travel. See how it's going to be halfway in between? So if we travel to 50 centimeters, halfway in between is 25. So that makes the x value of our vertex 25 centimeters. So it's 25 comma something. So then we need to determine the free fall time. So when an object is launched, it has its own, momentum that's carrying it up to here, and then it stops, and then gravity starts pulling it back to Earth. So this time right here is considered the free fall time. So that's half of the time that it's in the air. So if the object, if you timed it for 2 seconds, 1, 2, then the only time it's in free fall is 1 second, half of the amount. So then to calculate the y value of your vertex, x comma y, you're going to use this equation that relates to gravity. So you're taking d represents our y value of our vertex, how high off the ground. 1/2 is just the number 1/2. G stands for the force due to gravity. You're either going to use 9.8 if your calculations are in meters, or 980 if your calculations are in centimeters. Ours are in centimeters up here. And then t is the time of your free fall, t squared. So for our example, we're going to take 1/2. The force for gravity is that 900 centimeters per second squared. And we're going to multiply by 1 squared because it was in free fall for 1 second. So that tells me that the y value of my vertex is just half of 980. So 490 is the y value of my vertex. So my vertex is at the point 25, 490. 25, 490 right there. Once you have your vertex, you are going to use the vertex form equation for a quadratic. So for our example, the framework is going to be y equals a times, it's going right 25, it's going up 490. Do you see a piece that you still need to solve for? You need a. You need the steepness of the graph. To solve for a, you're going to use the coordinates where the projectile landed. We landed up here at the point 50, 0. So we're going to use the point 50 for x and 0 for y and solve for this missing a value. So the algebra that we need to solve is 0 equals a 50 minus 25 squared plus 490. Parentheses and exponents go first. So this is the number 25 squared. And 25 squared is 625. So a times 625 plus 490 equals 0. You're going to subtract 490 to the other side. So you get negative 490 equals a times 625. So your last step is to divide by 625. So a is negative 490 over 625. That's your constant for your concavity. So our final equation would be y equals negative 490 over 625, x minus 25 squared plus 490. So that is the equation of the catapult projectile that I'm looking for based on your catapult today. So then I did a couple more examples with them during class. So if you want to try these couple examples and pause the video, then I'll talk through how to do these 3 examples. So you probably want to pause the video now or watch the video, but we've got a 12-meter launch and it went for 5 seconds. So the X value is going to be 6 because that's halfway. The Y value is going to be 1/2. I'm going to use 9.8 for gravity because I'm dealing with meters this time. And time would be 2.5 seconds of free fall squared. So that gives me a calculation value of 30.625. That is the Y value of my vertex. So Y equals A, X minus 6 squared plus 30.625. I'm going to plug in my landing coordinates of 12, 0 for X and Y to solve for A. So this is 6 squared is 36. So 0 equals A times 36 plus 30.625. So to solve for A, I'm going to subtract this 30 to the other side and divide by 36. So A is going to be negative 30.625 divided by 36. So to write your final equation, it would be negative 30.625 over 36, x minus 6 squared plus 30.625. That whole thing is the equation of this projectile's path. So if you want to try one more example here, we did example 2 together as well. So you might want to pause the video and try this one on your own. And now I'm going to complete it for you. So the vertex is going to be at half of 57. So 28.5 comma something. I'm going to do 1/2. Gravity I want to use 980 because I'm in centimeters. And 0.7 squared is half of the time squared. So 0.5, 980, 0.7 squared gives me 240.1 centimeters as my Y value. So Y equals A, X minus 28.5 squared plus 240.1. I'm plugging in the landing site of 57, 0. So my A value will be negative 40.1, negative 240.1 over 28.5. Is that right? What's 57 minus 28.5 squared? 812.25. So my final answer should be negative 240.1 over 812.25 x minus 28.5 squared plus 240.1. So that's what we did together as a class, and then they had to go off on their own and complete these. You could just do it on a scrap piece of paper or print this off Google Classroom. You're doing your 3 trials with your projectile and your catapult so that you can use your average time and your average distance to do your own calculations for your own equation of your projectile. Tomorrow we are not meeting face-to-face. We're going to meet virtually, and I'm not doing a Google Meet, so your assignment will be posted in Google Classroom. Thank you.